Hey, so I wanted to do a quick video on an issue that I've been running into with the Circuit Adafruit Crickit board having to do with MicroBit. It's kind of a weird one, and I haven't seen anyone post about it, so I'm going to kind of go over that here really quick. So this is the project that I'm working on. It's the it's a mini smart home using the Adafruit Crickit. From Adafruit. And basically, I'm trying to get this door sensor to work. And I've had some issues. So I'm doing a digital read off of these sensor pins. And the problem I was running into is if the door is closed and the read sensor is engaged, the read sensor right here, basically the signal stays pretty secure. So it will pull that to low or pull that pin to ground. The problem happens when I open the door and that read sensor is not engaged and my digital pin is floating. So I'm going to show you, luckily that pin also does analog, so I did an analog graph of it. And I'm going to show you what I'm getting here. So basically, I'm closing that door right now. So now the sensor is engaged. And you can see it's basically, the top red one is that door sensor. So it's hanging around like 13, 12, sometimes dipping down to 1 voltage as a reading on it. It's not necessarily voltage. But basically, you can see as the graph gets into there, there's a little bit of peaks and valleys, but it's low enough to consistently pull that pin to low. The problem is when I open it, now it goes up too high, but you can see it's dipping way down below. And what I noticed is this is what happens. So basically in those peaks, it's going to go high, so it's going to read one thing. In the valleys, it's going to read low. So what was happening is with the door open, I was getting a door open, door close, door open, door close, switching back and forth instead of a just door is open signal. Now, this is an issue like I was following the instructions on how to do a push button. A read switch basically works a lot like a push button in there. So I wasn't sure what was going on. So the bottom one, the green one, this is pin 8 on the same rail that's doing an analog read. And there's nothing in it right now. So you can see there's nothing in it. It's getting a fluctuation. It's staying anywhere between 856 down to 818 with nothing in it. Now watch what happens. I'm going to so this is just a piece of wire, and I'm going to plug it in to the digital sensor and watch what happens to my green signal. So now you can see this was that previous signal before. Now you can see it is wildly fluctuating up and down. If I take my finger and I touch it, you can see that produces a big result. Even if I touch it on the casing, if I bend it. So it's very susceptible to interference. And that's not even connecting it to anything else. Now, if I take this wire and I connect it to my high side, it is going to go very stably, or sorry, that's the ground side, so that's going to pull it low. If I connect it to my positive side, that is going to pull it consistently high. So the digital pin is working successfully. Here's what is going on that I figured out. This is how I fixed it. So normally with a digital pin like this, you would have a pull-up resistor. So I'm going to show you how I fixed this. I didn't have a 1K or 10K resistor, which is normally used for this. This is a 47 ohm resistor, and I already have it plugged in with my signal wire over here on one end, and the other end is just floating. So what I'm going to do is stick the other end into the positive, and now look at my graph. Oh, I don't think I quite got it in there. There we go. So now look at my graph. It is stabilized. I have that pin. When it's floating, it's pulling to high voltage. So it is high, and now when I close the door is going to pull low, and that is consistent. So this is the fix, is just like wiring in a traditional button for older microcontrollers or like an Arduino. You do want to pull your digital pin too high. I mean, you can pull it to low as well, but you do have to put your resistor in there right now. I think yeah, and even with that in there, you can see there's a little bit of a fluctuation, but it's not nearly as bad. So now on the low end, it's staying at 23 to 0. So that's enough to where the digital will detect it. So basically that's it. What I suspect is going on here is that either the microcontroller that they're using for the Crickit board doesn't have pull-up resistors to assign to the digital pins. That's kind of a common thing right now, so that may be a bit of a stretch, although I have run into things like the ESP8266 does not have pull-up resistors, so I do have to use that whenever I'm doing a button press for things like the ESP8266. But the other thing that I suspect is someone may have missed in the code for the Crickit itself to define those digital pins as using a pull-up resistor. That is something even on Arduinos that you have to specify. It's become a common enough thing, people doing push buttons on there, that I don't know if they've even changed it to like default pin, but there are two different types of like digital pin designations that you would do for an Arduino. So it's likely just one of those two things that's happening, because the buttons, your typical button, if you were just to plug a button in there, the metal leads are short enough that it doesn't really get as much interference. But when I did plug when I did plug a button in there, I did end up with similar interference. It was just within the tolerance to where you wouldn't have detected it with the digital read. So it still would be effective. But if you were to put that button on longer wires, about like 5-inch wire like I'm using, that gets it to where it's big enough enough of an interference to where you'd probably run into issues. So if you run into weird things where your digital pins on your Crickit are going up and down when it's not, when a button is not pressed or a switch is not engaged, that's probably your issue. I don't know if this is an issue just with the MicroBit version of the Crickit, because I know Adafruit doesn't make the MicroBit, so it may be something they didn't anticipate with that or aren't aware of. I do have a Circuit Playground Express Crickit at home, so I'm going to test this exact same thing now that I know what the issue is on that, and yeah, hopefully this will help someone out if you run into the issue, because it took me a little bit of time to figure this one out on my own. But thanks for watching, and hope I helped.